All right, so we're going to look at some of the graphs. We're actually going to start, we'll go back to number 9. I want to start with number 10 because there's a lot going on. It's a good example. So remembering first that the number at the end of your equation, not the end of your exponent, is always going to be your horizontal asymptote. That's that boundary or that horizontal limit that where your graph sort of levels off. So positive 1 is going to be your horizontal asymptote. And your domain for these is always negative to positive infinity. So you can almost just put that down right away. So we've got 2 times 1/3 to the power of x minus 2 plus 1. We're going to go ahead and graph that in our calculator. So in your calculator, clear out anything that might be in there. And we'll type this guy. So 2 to the power of 1. Then to do that fraction, 1 divided by 3. And then your exponent I'm going to put in parentheses. So then x minus 2 plus 1. We're going to graph it. And then hopefully you guys can sort of see that your horizontal asymptote is there at the positive 1 when you graph it too. So that should match what you sort of said your asymptote was. So again, just one more time for typing it in. Start with your 2, and then you just have to do division for the 1/3 to the power of x minus 2 plus 1. And then you guys can go to your table to get your points. And I have them right in here. Okay, so we can't really plot negative 155, but we'll, and 0, 19. But the 0, 19 is your y-intercept, so we can, or we do at least need that information. And then 1, 7, so 1, 1, 2, 3, 4, 5, 6, 7, 2, 3, 3, 5/3. And I'm just sort of going to draw it in like so. Okay, so range corresponds with that horizontal asymptote because that's the lowest point where your graph goes. So your range is going to be from that asymptote, which is not included. So 1, parentheses, and then goes up. So positive infinity. Okay, let's try another one. I'm not sure why I started with number 10. We're going to go back up here and look at number 8. So flip backwards, looking at number 8. So domain automatically negative to positive infinity. Horizontal asymptote, value at the end of your equation, so negative 3. I'm going to draw it in. Okay, and then we're going to graph it. So 4 times 2 to the power of x minus 1 minus 3. Get your y equals, clear that guy out. So 4 times 2 to the power of, in parentheses, x minus 1. Get out your exponent, close the parentheses, minus 3. Graph it. Hopefully you guys can see horizontal asymptote at negative 3, so that's good. Go to your table. Fill in your points. And graph them. So we got negative 1, negative 2. 0, negative 1. 1, 1. 2, 5. And 3, 13 does not fit, so we will just not graph that one. Okay, so y-intercept, or you can look at your graph, but it is going to be negative 1. The y-intercept, again, is not a super vital point, just a point that we like to have you guys identify. And then the range is from that horizontal asymptote up. So the range is going to be from -3 to positive infinity. Okay, let's do number 7. So domain, negative to positive infinity. Horizontal asymptote. Okay, so what is the horizontal asymptote? If there's no number at the end, we would never put it, but these all have a horizontal asymptote. So if there's no number there, it's just automatically at 0, which is fine. So this horizontal asymptote is going to be right on that y-axis, right at 0. But we can go ahead and graph it in the calculator. So 1/3 times 3 to the power of x. So 1 divided by 3 in parentheses, that's the only way to do a fraction. Times 3, your exponent to the power of x. Graph it. Should see that asymptote's at 0 right on that x-axis there. Go to your table and then fill out your points listed there. So in the calculator, I have them as fractions. In the calculator, they'll be decimals. But -1/1/9, so maybe like right there. 0 1/3. 1/1. 2 3. 3 9. We'll squeeze it up there. And then you can draw your graph in. So y-intercept, also on the graph. Y-intercept's a third, or 0.3. And again, the range, your graph starts at that asymptote and goes up. So your range is going to be from that asymptote, which is 0, parentheses, up is positive infinity. We've got to do the negative graph yet, just because that's going to flip the range a little bit. So we're going to go back to number 9. And I actually, since I've got the points here, I think you guys have enough practice with typing it in the calculator. If you did, just remember we're putting it in as a fraction. So this would be y equals -2 times 3/4 to the power of x in your calculator. Okay, but horizontal asymptote and a number at the end, so at 0 again. Domain is going to be negative to positive infinity every single time. I actually have my points here. They're not nice ones. That's okay. We can still plot them. So -1, -2.6, so about there. 0, -2. 1, -1.5. 2, 1.1. And 3.8. So it almost looks like a line, but we need to draw a curve so that we can see that it's exponential there. All right. So what's your y-intercept when x equals 0? Y is -2. Okay, so this one, for the range, because it's going down now, the lowest point is actually negative infinity. So it's coming from negative infinity and stopping at the asymptote. So that's just when your range switches, and instead of starting with the asymptote, your range ends with that asymptote. So sort of from negative infinity to 0. So Domain is always negative to positive infinity. Horizontal asymptote's always at the end of your equation, not the end of your exponent. And then you can find your horizontal or your y-intercept just from graphing it. And your range will be based off that horizontal asymptote. It's either starting at that horizontal asymptote or ending there. But everything will be in parentheses for your domain and range, never including anything with these graphs.